So, hi everyone, my name is Edward and I'll be presenting target 6 from the round that you just took. So the question reads that there are 4 lines, 2 of which are given and 2 of which are in terms of variables, and the 4 lines enclose a region that is in the shape of a square with area 90, and we'd like to compute the value of the largest possible value of ABCD. So the first step we're going to do is plot the 2 lines that we are given and find their point of intersection by setting the 2 equations equal to each other and finding that their point of intersection is at 3, 13. So we also know that the area inside the 4 lines is a square. So that means that each of the lines will have 2 of the corners of the square on it. So, and we'll also know that the 4 lines will form 2 pairs of parallel lines. So without loss of generality, we can just say that A is 3 and C is -1/3. And now we just want to find what B and D are. So since the area of the square is 90, the side length of the square is square root 90. So if we let Q be the second point on the green line, so Q will be somewhere on the green line, not on the blue, then it will satisfy the equation y equals 3x plus 4. At the same time, PQ is a side length of the square, so by Pythagorean theorem, we have 90 is equal to 3 minus the x coordinate of q squared plus 13 minus the y coordinate of q squared. And by substituting what we had in the beginning, we can get that a quadratic, which yields the x coordinate of q is 0 or 6. So from here, we can find the y coordinate for each of these points respectively, which will be 0, 4, and 6, 22. So from here, we can find D, because D is the y-intercept of the second line with slope -1/3. And since we have the 2 possible points, we can just find what D is. And in this case, D is 4, 24. So now we'll do a similar strategy to find what B is, but since the sides of a square are perpendicular to each other, we can notice that Q is 3 units horizontally and 9 units vertically from P. Remember that P is 3, 13. So that means that S, which is the second point on the blue line, will be 9 units horizontally and 3 units vertically. So either S will go 9 units in the positive X and 3 units in the negative Y, or S will be from P, or S will be 9 units in the negative X and 3 units in the positive Y. So that means that we can easily calculate the possible coordinates of S. So from here, we know that S is on y equals ax plus b. A is 3, so we can just find what b is by isolating b. So b is either -26 or b is 34. So now we have all of the 4 different values, the values of the 4 different variables. So AC is always going to be -1. So then the product ABCD is just going to be -BD. So to maximize ABCD, we minimize BD. And that means we take B equals -26 and D equals 24. And that gives us the maximum value 624. And that is the final answer of target 6.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.